right, Mathletes, welcome back to Dr. Math Studios, and today we are going to be looking at factoring sums and differences of cubes. All right, so I have some very helpful tips for you. If you can, I would write this down or keep this handy, maybe on the index card when you're doing these types of when you're finding these types of factors, because you're going to see these are going to be clutch, right? This is a pro tip for you right here to have this. If you don't want to have this on the index card, so you can't use this on notes, I would just get a tattoo with all these perfect cubes. That's an easy solution. Just kidding. All right, so first of all, we're going to be utilizing these two formulas. So we have the difference of cubes, right? They got perfect cubes right here. And I'm going to show you how to use this formula. And then we have our sum of cubes. So whenever you see an addition of two perfect cubes, we're going with this formula right here. All right, so first question is, when I look at this, do they have a GCF? Always, 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 when you're factoring, ask yourself that question. In this case, the answer is no. So I want to identify that I have something cubed here, right? So my first thoughts are, oh, can I use one of these two formulas? And of course, I would check to see, can I use this top formula? Because I have a subtraction, a difference. But are these perfect cubes? This is where my list comes in handy, because I could see that if I take the cube root of 8 here, it's 2, right? And if I take that 27, if I take the cube root of 27, I get 3, because 3 cubed gives me 27. So I want to rewrite this so I have this in a nice format. So here, 8y cubed is really the same thing as 2y. And 3 cubed, just as we saw over here, right? 3 cubed, that's the same thing as 27. Because this is going to represent my x, right, in the formula. And this is going to represent my y. Maybe in some of your notes, your teacher may have wrote it as a cubed minus b cubed. And that's a good idea too. So this would be like my a and this would be my b. But again, they're variables. It doesn't matter. So now that we have our x and our y in this formula, let's go ahead and substitute everything in. All right. So we're going to end up with 2y minus 3. Right, and I said minus 3 because we're using this formula up here. So it's x minus y. It's the first term cubed minus the second term cubed. All right, and then we're going to multiply that by x squared. But notice, our x value was 2y, so we're going to square that. So when I square 2, I get 4. When I square y, I get y squared. All right, let's continue with the formula. It says plus, so let's write our plus. And it tells us we're going to multiply our x and y values. So we're going to multiply these two values. So 2 times 3 is going to give us a 6, and then we have that y. And last but not least, it says plus y squared. So we take that second term and we're going to square it. So plus y squared, which is 3 squared is 9. All right, so this is how we're going to factor the difference, right? That's what we looked at here, the difference of cubes. And again, if this is a little confusing because our formula has x and y's, we could rewrite it. And I'll show you how to do that in the second example here. All right, so looking at the second example, notice what I did for you. I just rewrote it. Instead of writing x and y, I just wrote a's and b's. So hopefully it's less confusing. And so I have some good news. This week at Nob Hill, you have broccoli for $1.77 a pound. Nah, I'm just messing. Who cares about that? No one needs broccoli. All right. So again, what we're going to do is we're going to rewrite this as something cubed minus something cubed, if possible. If not, then we cannot use our sum and difference of cubes formulas. All right. So this only works when we can rewrite these as something cubed plus or minus something cubed. All right. So notice, my first question to you is, can I use this formula here? Good. If you heard the person behind you, they said no, because this is for when we have a plus. But here we have a difference, right? So we wouldn't be able to use that formula. We would have to use the other formula that we looked at. So what I'm going to do is let me just change this problem to an addition, just so we could apply this formula. All right, so here we go. So what cubed gives us 64? And if that chart was helpful, then bring that chart so that could help you out. All right, so we have that chart here to help us out. So let's look at it. So what cubed gives us 64? So 4 cubed. So 4 cubed gives us 64. And then using that same chart, something cubed must give us the 125. So 5 cubed gives us that 125. So we'll put that 5 right there. And don't forget the x, all right? Because sometimes, I had a bad joke. Ignore that. Alrighty, so here we go. Now we know what our A term is, and now we know what our B term is. So let me actually write that out, because that might help some of you in YouTube land. So this is my A, this is my B. So now all we're going to do is grab these and plug them into our formula upstairs. All right, so let's do that. All right, so I get my formula says A plus B, so I'm going to have A plus B. So we have 4 plus 5x, and then we're going to take that A term and we're going to square it. So we're going to take this 4 and we square it. So 4 times 4, that's how we get the 16. Then we have minus, ignore that little dot. I've been using Clorox, I can't get rid of it. Minus, it says A times B, right? A times B. So I'm going to multiply A times B. So 4 times 5 gives us 20. So we have 20x. And it says plus B squared. So B squared, so 5x squared. So 5 squared is 25. And x squared is just x squared. So once again, we have found the factors of this right here. All right, folks, so hopefully that's helpful. If you have any questions, comment down below. Don't forget to like, subscribe, and spread the word, because I have a feeling a lot of people are at home right now doing all kinds of math. All kinds. Talk to you next time.